So here we have two functions, and the question at hand here is, what is the domain of each of these functions, and what is the range of the functions? The domain is basically for what values of x is the function defined, can we calculate it, and the range tells us what outcomes we have, so what the function values take, what range of values the function values will take, and sometimes of course we label that as y. So the domain, if there isn't an explicit domain, there are a number of reasons why a certain value may not be part of the domain, and the three we are typically looking out for is that in a function, you can see here, for instance, we're having a ratio 1 over x plus 3, and when you have a ratio, if you have a division, the things which you cannot do in a function is divide by 0. So we need to avoid values of x which would imply a division by 0. We also cannot calculate the logarithm of either 0 or a negative number, and we cannot take the square root of a negative number, at least not unless you want to allow for complex numbers, which we're not contemplating here. So these are the three things we're typically looking out for. So let's start with g, with our g function. So the danger here is this guy here in terms of the domain, because that potentially would allow a division by 0, or would ask for a division by 0. So we have to be careful, because x plus 3 cannot be 0. So for what value would it be 0? Well, if x is negative 3, then x plus 3 would be 0. So, sorry, x equals negative 3. So x equals negative 3 cannot be part of the domain. Therefore, but all other values of x are fine, because that can be negative or positive, so there's no other reason to restrict. So the domain for g of x is that x is element of all real numbers, but, and we indicate that with a vertical line, so that says but not x equals negative 3. Okay, so alternatively, you could say that x is element, and you could do it with two intervals. You could either say, remember, round parentheses mean they are not included, so either x is in the interval negative infinity to negative 3, or x element of 3 to positive infinity. Sorry, negative 3 to positive infinity. So remember the round parentheses here, let me make them red. If you have round parentheses in interval, they mean that this boundary value is not included, and that's important because negative 3 would imply a division by 0. So let's now think about what the function will look like. Let us just draw a little coordinate system here. So we're only sketching this function, we're not being precise. So we're having x on the vertical axis and f of x on the vertical and x on the horizontal. So we know something is going on at -3. Let us put this here. So at the value -3, this function is not going to be defined. So what happens if, for instance, thinking about how the function looks like and therefore figuring out what the range of the function is, so what values f of x takes. Usually we're looking somewhere at the boundaries to understand this. So let's start with very large x's. Right? If you have a very large x, if you sub in a very large x, then the denominator in that ratio will become very large. So we're having 1 over something very large, which is approaching 0, and all that we are left with then is this -5. So something is also going to happen at, let me put that in black, at -5. So -5, that is this value. Something is also going to happen here. That's a significant value for this function. So turns out that if we have very large x's, then this term here becomes very, very small but positive. So for very large x's, our function will approach -5 but from above. Okay, so we figured out how this looks, and perhaps we can immediately try and figure out how the function looks like for very small x's. So if we are going to -infinity here, well, -infinity means again this term in absolute terms becomes very small, but it is slightly negative. So very close to 0 but negative. So that means we have something very small negative, -5. So that means we're approaching the -5. So we are asymptoting, as a technical term, -5, but from below, because we are still having something negative to go there. And now we can think of what happens at this value of -3. So if the x, so look at this term here, if this x term approaches -3 but from the positive side, so let's say -2.5, -2.6, -2.9, -2.99, and if you think about it, what happens here, that denominator term, so let's say with -2.9, will be -2.9 plus 3. So it will be something small but positive. And the closer we go to -3, the smaller this denominator term will be. And if the denominator gets very small and the numerator stays with 1, then overall this term will become very large. So that means that this function, as we are going, approaching -3, but from the right-hand side, the function will go to infinity. Okay, so, and then in between the function behaves roughly like this. So it's a smooth transition here. What about if you're approaching -3 from the left? So let's say -3.5, -3.4, -3.1, -3.05. If you do that again, this term here becomes very small but slightly negative. So we have -1 over something very small is, this will approach -infinity, then -5 on top of it. So this term here, I haven't really left myself a lot of space here, will asymptote here to that -3 vertical axis, but will shoot down to -infinity. So this is what this function roughly looks like. Let us move on to the second function, the f of x function, and we're going to replicate it here again. So we're having f of x is equal to square root of x minus 2 over x plus 1. So the two things we got to be aware of here, and this is a slightly more advanced question, or it's a more advanced question actually. what we need to be careful is that we are not dividing by 0. That means x plus 1 cannot be 0. Cannot be 0. And we're taking a square root, and we don't want to take square roots of negative numbers. So the entire term x minus 2 over x plus 1 has to be larger or equal to 0, because square root of 0 is fine. So the easy bit here is what follows from that first condition. What follows from here is that x cannot be, or x has to be unequal to negative 1. Okay, because if x was negative 1, the denominator would be 0 and we would be dividing by 0. So negative 1 cannot be in the domain. Now, what follows from this is just, we'll have to think in a slightly different way here. So this has to be larger than 0. Now, there are different ways to think about it. Here's my preferred way. We're having a numerator and a denominator. This term will be large, or will be non-negative, if both numerator and denominator have the same sign. Okay, so there are two worlds basically we're thinking about here. Okay, either the denominator and the numerator are larger than 0, or the denominator and the numerator are smaller than 0. So two possibilities. Actually, what we have to take into account here, the denominator has to be smaller or larger than 0, because it cannot be 0. The numerator could actually be 0, because multiplying something by 0 is okay. So let's go with this world first. Okay, so either x minus 2 is smaller, or indeed, as it is the numerator, equal to 0. And what we then need is that x plus 1 is smaller than 0. So we need that, both of these to be true, such that numerator and denominator have the same sign. Let us just isolate the x's in these two inequalities. So the first one, we bring the negative 2 to the right-hand side, and the second one, we bring the plus 1 to the right-hand side. So we have x is smaller than negative 1. So we need x's, in this case, we need x's which are smaller and equal to 2 and smaller than negative 1. So the condition which is dominating here is this one, because if x is smaller than negative 1, then it will automatically be smaller or equal than 2. So let's go to the other option. Both denominator and numerator are larger than 0. Or, as it turns out, numerator could also be 0. We'll get to that in a moment. So here's the numerator, x minus 2. So this could now be larger or equal to 0. The denominator, x plus 1, would be larger than 0. That cannot be 0. So if both of these conditions are given, then denominator and numerator will have the same sign, and our ratio will be larger than 0. So again, we will isolate the x's. So we bring the negative 2 to the other side, and here we bring the plus 1 to the other side. Okay, so for this to be the case, these two conditions have to be true. X is larger or equal to 2, and x is larger to negative 1. So which one is the dominating here? It's this one here, because if x is larger or equal to 2, then the x will automatically also be larger than negative 1. So we have now identified what actually the domain of our function is. Let us draw a coordinate system. So, and now we're looking at f of x here. So we know that our x has to be smaller than -1 and larger, or larger or equal to 2. So these are important points here. The 2 and the -1. What we already know is that values in between do not belong to the domain. Okay, our x has to be smaller than -1 or larger or equal to 2. So now we want to try and figure out what the our function looks like. And again, we will be looking at the extremes. So perhaps first you can think about what does the function look like as our x goes to infinity. Okay, so as x goes to infinity. So we're having a square root of the x, which is very large, so think of infinity here, -2 divided by the x, which goes to infinity, plus 1. So what you can see here is that if that x becomes very, very large, the -2 and the +1 are almost irrelevant, but the numerator is slightly smaller than the denominator, so that entire ratio here is going to be slightly smaller than 1. And the square root of something slightly smaller than 1 is also something slightly smaller than 1. So that 1 is now an important value here. And as x goes to infinity, we are approaching 1, but we are staying just below. Okay, so we're getting closer and closer to 1, but always staying below 1. What happens as we go to 2? So remember, there's an equal here. So 2 is allowed. So as we go to 2, we're having, let's just go here, x. So we're looking at the numerator here. If that x is 2, we have 2 minus 2, which is 0. We don't even have to figure out what the denominator is. Square root of 0 is 0. So it means at this point here, the function value is 0. And in between, the function moves something like this. What about so we now figured out, so we've seen there is a part of our domain. In the middle, it's not part of our domain. And here, for values smaller than -1, this is again part of the domain of the function. So now we need to figure out how the function behaves here. Let's again think what happens as x now becomes -infinity for very negative values of x. Well, we'll think about the same again. So we are having x, which turns to -infinity minus 2 divided by x, which is -infinity plus 1. Okay, so what perhaps you can see here is that we're having something negative -2, so it becomes even a little bit more negative. And then we have -infinity plus 1, so that's a little bit less negative. So this turn will approach 1, but this time from above, because we are having the numerator is a little bit more negative than the denominator. So that value will be a little bit larger than 1. So think about if, perhaps that's not so easy to think about. Think about if x is -1000, then we have in the numerator, we will have, here, in the numerator we have -1000 minus 2 divided by -1000 plus 1. So that's the same as two negatives, they cancel out, but here we have 1002 over 999. So this is just a little bit bigger than 1, and the square root of that is going to be just a little bit bigger than 1. And the further we go out, the closer we get to 1, but we never hit the 1. And then lastly, we need to think about what happens as we move, our x moves towards -1 from the negative side. And what is important here to figure out or to see what's happening here is that denominator term. Because if the x was -1, that term would be 0. Now, we know that doesn't work. That's why we excluded that here. So it can't be -1, but if we approach -1, so if we're just a little bit smaller than -1, then this light blue term here will become very, very small. And above here, we have perhaps something very close to -1, -2, -2, so that's a little bit bigger than -3. So -3 divided by something very, very small, well, that will become extremely large, and the square root of something extremely large goes extremely large as well. So that will go to infinity here. So here's our function. Our function here has two parts again. This is one part, and this is the other one. It will never reach where -1 isn't part of the domain. So how would you write the domain here? We forgot to write this down before. So the domain of f of x is x element of -infinity to -1, or x element of an interval going from 2 to infinity. Infinity always gets a round bracket, and here now, because that value 2 is allowed, here we are having a square bracket. So that is the domain. So we can also think about the range here, and we'll actually go back to g of x. We haven't looked at that. The range, here we have a bit of space, the range of this function. Think about the outcome values which the function will take. And you can see here, you can read that off on the axis. It's going to be to infinity. It goes to infinity. It will never be exactly 1, because on both sides we're having an asymptote. And then it will take values up to 0, including 0. So the range is y, and let's call that y. Y is element of, let's look at that first interval first, from 0 to 1, but 1 not included, or y element of 1 to infinity. Infinity always gets a round bracket, and 1 is not included. Okay, so that is the range of our function. And let's perhaps go back to g of x. We didn't explicitly write down the range of this function. So what is the range here? Range of g of x. So again, let's look at our vertical axis. So we're going off to infinity here, going all the way down here, all the way to -5. -5 is not included, and however, we're going all the way down to -infinity. So the range, and that was g, I forgot that. So g of x is, well, we'll call that y, it's easier to write. So y is element of, it comes from -infinity to -5. Infinity always gets a round bracket. -5 is not included, so also a round bracket. Or from -5 not included to positive infinity. Okay, so any value of the function will fall into one of these two intervals. So just as a little recap, The important thing if you want to understand ranges for functions is that domains for functions, these are the three things you need to avoid: division by zero, a log of zero or a negative number, or a square root of a negative number. These are the things to avoid, and that will drive what the domain of the function is.